Thanks very much. Thanks for coming, everybody. And I know it's a really, really busy time, so I do appreciate you coming along to listen to me telling you just a little bit about some of my research, some of the things that have been occupying me in the last few years. Just quickly to start off, background, why did I get into this? What's my situation? Well, time spent in school, time spent in teacher education, quite a long time. And I found myself closely involved in the development of these pre-ITT and post-ITT subject knowledge enhancement courses, or SKIs as we sometimes call them now. And I started to become interested in what a bespoke SKE course could offer when compared with the other way into teaching, through a traditional route, doing a degree in maths, followed by PGCE. So we start to look at the differences between those different approaches. Some students come through, they do their degree in maths, or mostly maths, then they go to PGCE or School Direct. But some people come to us having done a degree in something else, do an SKE course, and then move on to PGCE. And in the team, we start to work out that the SKE course does things a little bit differently. And that started thinking about what does it mean about to have subject knowledge for teaching, and what do we need, and what's it all about. So the pre-ITT SKI, we still call this the MEC, the Maths Enhancement course here at Hope, and that's probably what you'll hear me calling it for the rest of the talk. We were one of the first to run it. We piloted it in 2004. It rolled out nationally in 2006 across the country. It's aimed at graduates who are not mathematicians. It's fully funded by government, still is. And the version that we run here at Hope is a 6-month taught course from January to June. And the point about it, it's a bespoke course, especially for intending maths teachers. I'm delighted that one of the graduates of the course is joining us today. Welcome, Chris. He's munching his sandwich. And what we find is that this course is generally taught not by academic maths departments, but by maths education departments in the universities. Tend to be the people who have most to do with the teaching on it, not exclusively, of course. What does it include? Well, a breadth of rigorous high-level topics that you might expect if you are extending yourself as a mathematician. You need to know some of the more abstract, rigorous mathematics, but also an in-depth study of school-level mathematics, so that you are better prepared to go into school, because everybody on the course, that's what they're going to do. They're going to be teachers. They've already got their PGCE or School Direct place waiting for them. And then some courses put extra stuff in, and of course, being here at Hope, we put extra stuff in. There's always distinctive features. We have school attachments, so the students do some observation in schools on 2 short placements, which works its way into a written assignment. Really good preparation for what they're going to come to do in their PGCE year, of course, when they do have to write at a high level. We do an intervention project working with Year 11 students from the city who need a bit of support. So, and the little extra things like that we put in. And then they progress to PGCE or School Direct or whatever it is. Okay, the post-ITT SKE, this is a course that used to be called the Maths Development Programme for Teachers. So we still refer to it here at Hope as MDP or MDPT. Again, we were among the first to run it. We piloted it, and I think there was a lot of learning that the team had, the maths education team, benefited from doing the MEC that fed into this, but it's aimed at a very different audience. These are the people who are propping up maths departments all around the country, I would contend. Virtually every school's got one of these, a non-specialist teacher of maths, qualified in some other subject, or maybe somebody who's come out of primary. But more typically, they're qualified secondary people, but they might have done biology or PE or some other subject. But then one day, the heads tapped them on the shoulder and said, well, we're a bit short-handed in maths. Could you do a little bit of Year 7, a bit of Year 8, just a couple of lessons a week? And before they know it, they're doing quite a lot of maths, but they know that they don't really feel that well prepared. So the idea of this course is to upskill those people. It's a subject knowledge course for people who want to. Already teachers, they know about teaching. They don't need to learn all that basic stuff that a PGCE student would need to learn, but it's the subject side of it that they need support with. So it's primarily a subject knowledge course, but of course we're interweaving that all the time with good pedagogical strategies. How would we teach this topic? What are good ways to approach certain things? We attach master's levels credits to this course here at Hope, and so do other providers, so that people can get on top of doing the SKE course. If they want to reflect in more depth on the pedagogy side of it, they can actually get a postgraduate certificate alongside, which some of them choose to do. And of course, if they do that, they get so much more out of the course, but it's pretty demanding. We've been running this since rollout in 2009 after the pilot, but in this year, 2014, everything's changed, and money is now going through teaching schools alliances, which means that we want to offer our course, but we have to do it working with the teaching school alliances. But actually, Hope are still doing virtually all the teaching, and some of the rollouts happening elsewhere in the schools, but they're not doing that much. They actually value what's going on here at Hope. They want us to keep leading it, and they're the conduit for funds, and that's fine, we can deal with that. I did hear today that David Cameron has today announced funding into the future for this course and others like it, because there are others in science subjects and other shortage areas. So he sees the need for having well-qualified science and maths teachers in schools, and of course upskilling people who are already there. It's got to be one of the cheapest way of doing it. It's very cost-effective indeed. So I'm pleased that this course, I know now, has a future beyond this year. Not surprised, but very pleased to hear that. Okay, from my point of view in terms of research, I got involved with Professor Jill Adler, who works based in South Africa but has also been attached to King's College in London for a number of years, and she was leading projects looking at understanding maths in depth, and we were looking at MEC students. So I started working on that project with that team, and that was my introduction really to working with a team of researchers. So I have a lot of credit I need to give to Jill for inducting me and supporting me in that early stage of learning about how to do research. Same sort of time, I came across other things that interested me about allied topics. About looking at what degree classification people come in with when they start PGCE and how successfully they exit PGCE. Is there a relationship? So I started exploring that sort of thing as well. There isn't a relationship, by the way, but more of that later. So I was starting to dip my toe in the water, really, trying out different things. Maths Enhancement course. This was the original specification, that the course should develop subject knowledge characterised by connectedness, multiple perspectives, and a deep and broad understanding of concepts, as against surface procedural knowledge. So this is one of the key ideas that influenced the research that I was involved in, and that those words in the original, taking that from this specification, I think, the original specification of the original MET course way back 10 years ago. Okay. What I'll do now is I'll just tell you a little bit about some of the key literature that supports subject knowledge for maths teaching. And some of this is generalisable across other subjects as well, of course, and some of it is more specific to mathematics. So it all starts, I think, for most people looking at the nature of teacher knowledge would start with the work of Lee Shulman back in the 1980s, and the idea of pedagogical content knowledge and subject matter knowledge. That kind of key distinction, knowing the stuff yourself versus knowing how to teach it. Very different things. And teachers need to have both, of course. Then the work of Deborah Ball in Michigan, who refined Shulman's model. And whereas people were finding that there was no relationship between the kind of what degree class somebody had, or whether they'd studied high-level mathematics at their degree or beyond, and how effective they were at teaching, there was a relationship between the way that they understood mathematics for teaching, and Deborah Ball and that team were developing research items to test just that. Okay. And they started to look quite critically about what is involved in teaching maths. So the demands of the work teaching maths create the need for a body of special knowledge, mathematical knowledge, that is special to teaching. Yeah? A maths teacher needs to know stuff that other mathematicians don't know. You need to know that maths in a different way. You need to hold it in a different way. And it's to do with anticipating what the learners need, but also it's to do with unpacking and breaking down the mathematics. And those of you who've studied mathematics, even as far as A-level, will know that the further up the rigour of mathematics you go, what we tend to see is that the maths becomes condensed. Indeed, it's supposed to be a sign of a good, elegant mathematical proof if it's very, very short and concise. So this goes against the grain, really. A maths teacher has to be able to unpack and develop mathematics for learners. Otherwise, you can't teach it, and they don't learn it. Okay, that's a special, special Ball and team elaboration of Shulman's original idea. Subject matter knowledge on one side, pedagogical content knowledge on the other side, and Ball and team have further broken that down. There are problems with categorisation models, of course. Not everything just fits neatly into a box, but it's a helpful start. I think it's helpful. Okay, it doesn't cover everything. So common content knowledge, that's the man or woman in the street, what they know. Specialised content knowledge, that's the bit that the teachers know. And then on the other side, pedagogical content knowledge, more about how we apply it in school. And there are many more people who've influenced this work. The literature on maths knowledge for teaching is quite strong. There's quite a lot of it, and it's growing all the time. So Hyman Bass and Deborah Ball working together. Knowledge of maths for teaching, you need to develop an awareness of subject matter that goes beyond what's normally needed for the man in the street or the woman in the street. We've got the work of Tim Rowland and team here in England, the Knowledge Quartet. Anne Watson also writes about, lots of key people are writing about knowledge for maths teaching. Anne Watson is one of the people who says we can't categorise it. And she has a more holistic view of what it's about. And she would argue that maths knowledge is more about being mathematical and acting mathematically. And that's really interesting. It's about what you do. Okay. Unpacking and decompressing maths I've already talked about. The great Mike Askew's got things to say about it. He suggests that rather than thinking about we having to learn a load of knowledge, that actually what we need to do is develop a mathematical sensibility, a disposition to the fact that, okay, I might not know this now, but I can have a go. I can work it out, or I can look it up, or I can phone a friend. But I'm not frightened of it. Now, Mike Askew, of course, as many of you will know, works very much in terms of, in the domain with primary education and primary maths teachers. Some of these other researchers have been mostly researching primary. But what I'm using here is what transfers across to secondary as well. Jeremy Hodgson suggesting that knowledge of maths for teaching is situated in the classroom. It comes alive in the classroom. Yeah, it's not always accessible and visible except through that. And Kenneth Ruthven talking about restructuring existing knowledge. And this is really important for my teachers on the CPD course. They've got a knowledge already, but they need to have it developed and restructured a little bit. They're coming in with something. Everybody's coming in with something, but it needs to be developed. And there's more. Just finished there on that little section with Davis. Teachers mathematics being a learnable disposition. We can all learn to do mathematics and learn to have a positive disposition and outlook on it. And his latest work, just recently published, talks about profound understanding of emergent mathematics. Okay, so that's a whistle-stop through some of the literature, and we end there with Lipping-Ma, really influential piece of work based on primary mathematics, and this was a comparison between Chinese and American USA teachers. And Lippy Ma coined the phrase profound understanding of fundamental mathematics, which is kind of the same kind of stuff that I'm looking at. And she talks about addressing teacher knowledge and student learning together, enhancing the interaction between teacher study of school maths and how to teach it. Now, I think that's exactly what we're doing here at Hope on primary courses, on MEC and other places, PGCE, but more of that later. Okay, so if I just tell you what I did, this is my doctoral thesis research. It came in two parts. The main research, the main investigation was a piece of qualitative work. I interviewed a sample of teachers. There were 21 of them altogether, and they were all either PGCE students at the time or former PGCE students, some of whom had done MEC and some of whom had come through a degree, or they were teachers on the CPD course, the Maths Development Programme. And I was looking for insights into those teachers' conceptions of what they think deep understanding of maths is all about. Okay, so that was the key piece of research. That's what most of the findings were. As a kind of contextual bit of background, I also did a bit of quantitative work, because I am a mathematician and I'd like to do a bit of quantitative work. I looked at entry and exit grades from some of the PGC students here across 3 years. And that was a group of about 100 students. And I just investigated what the data showed or didn't show. So I'll deal with that first, because that was really quite a minor part. Quantitative data. I asked the question, was there any relationship, any correlation between people's entry grades and exit grades? So by entry grade, I mean the degree classification that they already had when they started PGCE. And by exit grade, I mean the grade that we give trainees as they finish, usually grades 1, 2 and 3 it was in those days, to see whether there's, do people who come in with a higher degree classification come out with a higher exit grade from PGCE. And as almost anybody in teacher education will tell you anecdotally, there isn't really a relationship, and that was precisely what I found when I actually looked at it. There was no relationship beyond a certain level. We want people to come in with a certain level of qualification, of course, but beyond that it doesn't make any difference. Any difference between the PGCE students in terms of those who'd done the MEC and those who'd done a degree in maths? Again, on exit, no difference at all between them. They were just pretty much coming from the same population by then. You couldn't tell them apart. When I drilled down a little bit more to see, could we tell them apart in terms of their subject knowledge? No, you couldn't. So that was interesting, but it was only 100 students. It was only one university, so it's not really generalisable. So it's not the main part of my research, but there is somebody working on that stuff at the moment now. Rebecca Warburton Leeds has picked this up and is doing a much wider piece of work and taking data from various different universities. So that's happening. What she's found so far kind of supports what I've found in small scale. But I think we'll be hearing more from her. Okay, back to the main topic then. How is understanding maths in depth conceptualised? I wanted to know, what do people think it is? How do they think you get it? And what else emerges? What else were they talking about in relation to their own experience of maths teaching? So I was able to be quite open about that. So those were the research questions that framed the work. I then interviewed people. They were all people who were by definition at an early stage in developing their expertise as maths teachers. Yeah, they were all early maths teachers in one way or another because of the sample. I used a semi-structured interview, and each interview about half an hour or so. So what I'm going to show you now are some of the things that people said. So of that 21, 12 of them were PGCEs, about half and half MEC and non-MEC. and 9 of them were from the MDP course. So, what is understanding maths in depth? Understanding why you're doing it and where it applies. They need to be able to see that's where it's from. If you've got a deeper knowledge, then they will trust you, because they can sense that you do know what you're talking about. The people came up with some quite interesting things. This is all about hearing the voices of the teachers. Let me show you a few more. Someone who had a deep understanding would be able to see the links. When you're talking about someone who could see patterns in the way things work and the way the topics are interlinked with each other. Okay, this is the kind of thing. When I asked an open question, what does understanding in maths mean, in depth mean? This is the kind of things that people are coming out with. How do we get it? Because when I was learning my maths, and I'm still learning now, I live and breathe it almost. We're talking about understanding in depth. There's something, that a real understanding that not many people have. You've got to live with it. You know, it sort of takes over your life. Somebody said it takes over your life. Develops by living or spending time thinking about mathematical ideas. Because once you start enjoying something, you want to do more of it. Yeah? You get deeper and deeper knowledge of it because you read the books and you talk to people. Because math is a foreign language. And the best way to learn a foreign language is to go and live in the country, and that's what I'm doing. I'm living in the country of maths, as one person said to me. Okay. So, some quite interesting thoughts about their own development and how their own understanding was developing and changing at that time. Then I started spotting some themes emerging, and one of them was around identity, teacher identity and confidence. This is one of the MDP people. I'm a much more confident teacher from being here and doing all these things we've done. I'm more comfortable with it. I take it back to the maths department. I feel part of the maths department. This is a non-specialist. Yeah? Whereas 2 years ago, if someone had said to me, you'll be teaching statistics to year 11, I would have looked at them and laughed. And then she was. She was teaching statistics to year 11. It gives you a deeper understanding. It makes you visualise things, rather than just giving the kids a worksheet and saying, this is how you do it, get on with it. And that was a teacher who'd come across from a business studies background, was making a lot of use of pre-prepared worksheets, didn't really want to be asked any questions because he wasn't secure. And he knew he wasn't. Gave me a clear understanding of why these things work. And I now know how to draw ideas out of the learners, rather than going in and saying, this is how it works because it does, do as I say. Yeah? I started to anticipate questions of why, because I was never the why person. So there's a trainee saying, I was never the why person, but I am now. The course has given me the confidence to try new things. I now read stuff in the bath about mathematics. Somebody did actually say that. Anyway, moving swiftly on. That wasn't him, that was a random picture. I must reassure you. So you get all this data, you ask all these questions, and of course this is the social science side of it. Remember, I was a mathematician originally. And now I think Nick Almond stood up and said something similar not that long ago in one of these talks, and now I'm finding I'm dealing with different sort of data. And what do you do with it? You've got all these transcripts, you've got all these voices of teachers, and you're wanting to make some sense of it. Well, I'm not going to go into detail about the methodology, but basically there were 4 stages that I looked at. Firstly, I read through each transcript and started highlighting what to me was interesting. And why am I in a position to decide what's interesting? Well, I'm in that position because I've been involved with the course for a long time. I've done a lot of reading, and the professional judgment comes in to that situation. So you can justify that initial professional judgment, I think. Then I started looking for themes and annotating the transcripts, and then I looked across the transcripts, question by question, and doing a bit of a cut and paste to look and see whether common things occurring in each question. And that was really interesting. That revealed some interesting stuff. And by this time you forget who's who and what's what, and you've taken all the names off, and you're just looking for the paper, the data that's coming out. And then finally I went back to each individual again and reread, and I just put a post-it note on the top of each transcript, and I made myself write on the post-it note, which is small, what were the key things that were coming out of this interview. What was this person really saying? And this is what I found. In terms of the original questions, you know, what understanding maths in depth is all about, probably not surprisingly, you find that the PGC students, they're learning more about how to teach, whereas the MDP people are learning more about subject knowledge. And if you think about it, that's not surprising. The PGC people have got their subject knowledge already in place. They've done their degree or they've done their enhancement course. They don't know how to teach yet. They're learning that. That's what they're struggling with. You know, those are the skills that they're really grappling with during that year. The MDP people, it was more about identity and subject knowledge and confidence. And people perceived understanding maths in depth as being about knowing why and being able to communicate, interestingly. If you can communicate, if you can explain it, then it shows you understand it, one person said to me. Which is kind of the other way round from what people might think. But there was a very strong link to communication. And that's maybe what understanding something is like, what it needs to be like for a teacher. And development through spending time and investigating problems, doing mathematics, being mathematical, if you like. And then these are the themes that emerged. And they came through quite strongly, and I wasn't expecting any of this. I set out with some questions I wanted answers to, which I found. And then these things popped up as well. I started seeing that people were telling me that things that they'd started off being quite insecure about can become changed into areas of strength. That actually the time you spend and the thought you give something when you're preparing to teach it actually brings you on in terms of your own understanding yourself. People were telling me that the style of their teaching is different when the material is new to the teacher. It would be interesting, I think, to ask the same things of experienced maths teachers. I haven't done that, but you know, maybe I will. So we can develop deep understanding through preparing to teach something. Those 1, 2 and 3 were kind of linked to each other. 4 and 5, again, linked to each other. Growth in knowledge and confidence can alter identity, your perceived identity. People are thinking of themselves differently. I'm a maths teacher now, rather than a teacher of maths. Right? And reconstructing existing knowledge can really change the teaching approach. So those are the themes that really came out. So what? What do those themes tell us? Well, I think what the first 3 themes tell us is that we've got to integrate the development of subject knowledge and pedagogical knowledge, and I think in the best teacher education courses that is exactly what's happening. It's certainly happening here at Hope, and that came through very strongly, that the two can go hand in hand, and it's a very powerful mix. And themes 4 and 5 speak to me about the value of proper in-service training courses, not just a Saturday morning here or twilight there, but a sustained course, which the SKE is, over time, to really have an impact on how people work. And we really can develop non-specialists into maths teachers. 2 of the people who did that course I've seen in the last fortnight, they are now mentoring secondary maths trainees on the PGC course. They were non-specialists 5 years ago. I was delighted to bump into them in school. Didn't know they were doing it. You know, and you see that sort of thing all the time. Nearly done now, you'll be pleased to know. Implications politically, and some of this I'm hoping if I'm able to contribute a chapter to the faculty book, that'll be more about the political, if you like, or the societal implications. The MEC, or the pre-ITT SCI, now occupies a really important position in the maths education landscape, has done for a long time, but now a decade on, we can look back and say, well, yes, you know, roughly about a third of trainees, we estimate, who go through onto PGCE, now School Direct, will have come through from a MEC. So these courses are really vital. And they start to challenge and redefine the boundary between, you know, subject matter knowledge courses and pedagogical knowledge courses. Because you know, what do you teach in one bit and what do you teach in the other bit? You have to have those agreements and conversations. You have to make the distinction and draw the lines. And a number of MEC students over the years have said to me, anecdotally, informally, everybody should do one of these courses. Everybody should do a MEC. It's a really good course. Of course, everybody can't do a MEC because you're only allowed to do it if you've got a deficit in your knowledge, if you haven't got enough maths. But what it might be exposing is that actually there's a deficit in our traditional degree model. Traditional degree maths of the sort of degree that I did 30 odd years ago, and that's still happening, particularly in the more traditional Russell Group universities, don't usually have opportunities for people to learn about school mathematics in depth, and yet, you know, a number of those people will go on to be teachers. And Lee Shulman makes that comment, very same. Current undergraduate maths programs seem to have no place for teaching fundamental maths. Such knowledge is rigorous and deserving of university level instruction. We have some limitations, of course. It was only my research on this university, in one institution. I didn't go and observe any of those participants actually teaching. That would have been great to have done that, but I didn't do that. So I didn't attempt to investigate what I thought they could do and couldn't do. I asked them to tell me. So that's the approach. I didn't look at experienced teachers. These were all novice maths teachers in one way or another. It was a snapshot. I haven't gone back and revisited any of them yet. It'd be good if I could. And of course we've got the cultural spin as well. Do we need to understand something in depth in order to be able to do it? Not all cultures would agree. You know, there's a specific kind of take on that that some people would contest, and that's quite important to recognise. But it is some new work because it's about knowledge in and for secondary maths teaching. Maths education research, there's tons out there on primary, absolutely tons. There's less on secondary, so this is a small addition to what's there. I think I'm the first person that's put MEC and MDP people together to investigate them together and to listen to their voices. And then, of course, a little bit of quantitative analysis, although that was quite small. So to finish, my main thought, I suppose, at this stage is that understanding maths in depth requires active engagement, and it takes time. And that's whether you are a teacher learning to teach it better, or whether you're a learner in school, a child, pupil. You still need to take time about it, and you need to be actively involved in it. If those two things aren't happening, then you're not going to learn, I would suggest. And that's all fine. What's wrong with that? Well, the only problem with that is that we are working currently in a culture, performativity, a scramble for results, whatever results might mean. And I think there's a big challenge to us all, particularly to school teachers, to resist that temptation, you know, to teach to the test and get the short-term gain at the expense of long-term understanding. So that's a sort of a take-home message, really. Okay. And after that, I think, yeah, I've just got loads of references which you can look at if you wanted to, but that's it, finished. Thank you very much.